This is a pre-lab discussion on melting point analysis. The melting point is the temperature at which the solid and liquid forms of a pure substance can exist in equilibrium. In this lab, you will record the temperature at which a pure substance will completely transform into a liquid. Please read the lab before you begin the experiment. A pure substance will have a sharp melting point range of about 2 degrees Celsius. A very small amounts of impurities will lower the melting point and widen the range. Consider two pure solids with coincidental melting points. What would be the experimental melting point for cinnamic acid mixed with urea having a melting point of 132 to 133 degrees Celsius? By mixing these two compounds and crushing into a powder for uniformity, the experimental melting point will be lower and the range widened. The actual value of the range will depend on the ratios of the two compounds mixed. The point of this part in the video, add a scoop of two different substances and use a mortar and pestle to crush for uniformity. Remember to always use a clean mortar and pestle, dry if necessary before each use. Here is a literature report of mixing benzoic acid with acetylaldehyde. Notice their melting points are slightly different. For 100% pure benzoic acid, the melting point is sharp. You will also notice by changing the mole percent of benzoic acid to the mole percent acetylaldehyde, the melting point will change. Notice that by increasing the amount of acetylaldehyde, the temperature of the melting point is much lower and there is a wider range. In the purpose of this melting point analysis, we will not conduct a purity analysis by mixing different mole ratios of two substances with similar melting points. The main goal is to identify an unknown pure compound using melting point analysis. We can determine with good accuracy the identity of an unknown pure solid compound from a list of known compounds with their melting points. Here are the steps. First, run the melting point of the unknown solid. Then, use the table 1.2 page 2 of your lab manual to locate which substance it could be. Mix the unknown with one of the possibilities and run the melting point again. Continue with point 3 until the melting point is sharp. If sharp, then you have identified your unknown. Here is an example. Suppose an unknown has a melting point of 115 to 117 degrees Celsius. Don't forget, this is a pure compound. From table 1.2, the suspected possibilities can be acetylaldehyde at a melting point 113 to 114 degrees Celsius, mandelic acid, melting point 119 to 120 degrees Celsius, benzoic acid, melting point 120 to 121, and 2-naphthol, melting point 120 to 121. Thoroughly mix a scoop of unknown with a scoop of acetylaldehyde. Run the melting point. If the unknown and acetylaldehyde are pure, then the melting point is sharp. It should be close to 115 to 117. If there is a lower melting point and there's a wide range, then repeat with the next possibility, basically doing step 3 again. One note is the published melting point data versus the experimental melting point data. Often, the literature reported data for melting point is slightly different from the experimental melting point. Also, it can vary with different melting point instruments. And the reason for this is that the thermometer needs to be calibrated. Last note, melting point data can serve to identify an unknown. It is not the sole data used to characterize the compound. For instance, when a compound is synthesized and purified, a melting point analysis can indicate many possible compounds that contain coincidental melting points. Characterization is done using all other possible techniques available, such as IR spectroscopy, NMR spectroscopy, mass spectrometry, elemental analysis, and X-ray crystallography. First, it is good practice to make sure that the melting point apparatus is not hot. You can place some ice directly over the aluminum base and mop up the water with paper towel, or check the thermometer so that it's around 20 to 25 degrees Celsius. With a pair of tweezers, pick up a clean cover slip and place it over the aluminum heater. This is the first cover slip that keeps the metal clean. Next, use a micro spatula. Place a small amount of sample on the cover slip. Then, using tweezers again, pick up another clean cover slip to place over the sample. The sample is now sandwiched between two cover slips. These cover slips can be disposed in a waste beaker or aluminum pan that is nearby. Never use the tweezers to transfer the crystals.